our final project. The team is formed by Carolina Bonilla, Paula Iracema Hernandez, Ana Paula Garcia, and Maria Belén Saavedra. This is the project for unit mass transfer operations, and this project is composed by an introduction that includes all the topics seen in the semester autumn 2019. And after that, we created 2 problems, including 3 operations or three topics by each problem, and then we solved it and made a conclusion about the problems. The main topics we saw during the semester was the separation of the mass by membranes, by phase creation, phase addition, by barriers, and also we saw the absorption, humidity, drying, and mechanical separations such as clarification, filtration, sedimentation, and particle size reduction. Also, we studied the mathematical models such as Henry, Langmuir, and Freundlich. Now Ana Paula will explain the first problem of the project.
The first problem is inspired in a real-life problem that happened in a chemical industry where they granulated the final product, but the granulator was washed before granulating and the water remaining there was absorbed by the final product, and this caused that the final product had a higher moisture content than the one that they desired, which lowered the quality of the product. Taking like this example, we designed a problem, but focused in a textile industry. In textile industries, they use a lot of water, especially for washing their raw material and their products, and the water they use is the residual water has a lot of pigment content, a lot of dyes, which need to be treated, because if it's disposed like that to any body of water, it contaminates it and affects all the living organisms in there. So in order for us to dispose water, it needs to be treated. This is why we designed this problem to use activated carbon to treat this water. First, the carbon is activated and it's granulated to reduce its size. However, as in the real-life problem I said, the granulator was washed, so it had a lot of water content, which caused the carbon to absorb this water. This saturates the pores and reduces the efficiency of absorbance because there is not a lot of surface area where the dye can absorb to the carbon. Since this is a problem, what they did in the industry was to use the raw material of the carbon activated. They put it through a dryer and an adiabatic dryer, so they can remove the moisture or the humid content and use it as an efficient absorbent.
Okay, in this part of the problem, we talk about the adiabatic dryer. So we used the results that we got there and used the psychometric chart in order to analyze and to understand the results. The psychometric chart has some parameters such as dry bulb temperature, wet bulb temperature, dew point, relative humidity. So all of this information help us to understand the behavior of the activated carbon. And after the drying, we used the mathematical models in order to know which one fits the best. So we used Henry, Langmuir, and Freundlich, and we got the result from the errors, and we got for Henry 32%, for Freundlich 80%, and for Langmuir 9%. So we decided Langmuir was the best mathematical model, so we use Langmuir for this problem.
Another 2 questions we wanted to answer with this problem was how long will it take to dry the activated carbon, because it's important to know the time so it can be adapted to the industry process, and how much water was evaporated if 100 cubic meters of air were introduced to the dryer. Both of these parameters are important to know how much air will be needed, to know if you can use the water that's evaporated in another process, maybe to reduce the cost of drying, and to make sure all your process is efficient and with the time you need it to be done.
To summarize all the information we just said, in this project we studied the absorption, the reduction of the size of the particles, the mathematical models, and the adiabatic drying.
Throughout this project, we learned that working as a team helps you complement each other's ideas to have a more developed problem in this case, but also it's very helpful to apply what you've learned in class to a real life problem, like being able to relate a real life chemical industry problem to our problems, and even using the information you have for investigation problem and processes, or using it as a thesis theme.
Okay, and just said that Paola, Iracema, and Carolina will tell us the second problem. Thank you.
Thank you.
Hi, we are Iracema and Carolina, and we are going to present the second problem. In our second problem, we want to purify toluene. Toluene is a solvent that is widely used in the paint industry. In this case, we want to purify toluene because it's mixed with water, and we need pure toluene. So we get to absorb the water from the toluene. For our industry, the paint industry, toluene must be pure in order to get in our products. And we have a mixture of toluene and water. Because of the toluene low boiling point, in order to separate toluene and water, we get to absorb water from the toluene. In the next diagram, we can see the separation units applied in our process. First, the water is absorbed from the water-toluene mixture to obtain pure toluene. This with the absorbent of activated alumina. Activated alumina then goes through a dryer in order to remove the water that it absorbed. And after, the water must be used in another process, so it must be cooled. So first of all, we want to compare the isotherms of absorption of activated alumina with water. In this process, we use the three models: Henry isotherm, Freundlich isotherm, and Lamour isotherm. In this occasion, we couldn't use the Henry isotherm because the behavior of the graphic wasn't linear, and we found out that using Lamour isotherm is a better fit for our process.
Secondly, once the adsorption happened, we wanted to dry the activated alumina in order to use it again. We wanted to dissolve it, and we did so by using plates, and we calculated the amount of humidity that remained in the activated alumina with certain conditions after 3 hours. And finally, we retrieved the water that was evaporated from the dryer, and we want to reuse it in another process. To do so, we have to first cool it by using a heating exchanger, and we calculated the amount of heat that was lost in this process.
So this problem was really useful because we get to apply the knowledge that we acquire in the classroom in a practical problem. It's a problem that is used in the industry. It's not just from a textbook, and it helped us to understand better how every formula we use or every separation process that we learn
in class can be applied all together in one problem that is one industry.
We also had to work as a team, and it really helped us because we created a good job in a faster way and in a better way than if we had to do it alone. So this class also helped us to integrate those skills into our job.
Also, the class was really helpful in other subjects because we see many of these processes in other classes, but we don't know how they work. So in mass transfer, we learn how many equipments work and what's the principles behind them.
And that's all. Thank you.